Welcome to our Live with Andrew mathematics lesson for today. This is being filmed live on Tuesday the 21st, and this is the third part of our math series. We will be putting the other two lessons on YouTube, and this lesson will be available on YouTube as well. We are doing mathematics today, and as always, as we start, I hope you and your families are still safe and everything's going good. It looks like we may be starting to hit the crest and be going back down the hill, so that's good that things may be getting back to normal sooner than later. So that's kind of exciting for us, but still, I hope you're staying safe. But as always, I try to use humor to make it through things. And when we look at it and go, well, how long have we been on lockdown? This is one of my favorite memes, the little girl that's kind of looking at you like, what are you talking about? Yeah, she's grown up now. So that's how long it seems that we've been on lockdown. And just a quick question. Can we take showers, or do we just keep washing our hands? They keep talking about washing our hands, but they don't say anything about showers. So starting to get a little rank around here. We need to shower soon, but just kidding on that one. And then the last one, this is your pilot speaking. I'll be working from home today. That's a profession that you can't really work from home. Fortunately, education, we are adapting and we're able to work from home, and it's not quite as scary to go through as you would be if your pilot's working from home today. But hopefully y'all will be getting the information and you will be able to kind of continue as we're doing it. Please follow us on Facebook and subscribe on YouTube. Like I was mentioning before, some of y'all may have come on as we were doing this. Search for Rankin County Adult Education on both of those if you are trying to find us, and you'll see some of the content that we're putting out. All of our Live with Andrew series are posted on YouTube afterwards. So today's lesson, you'll see it on YouTube. Some of you may be watching it on YouTube right now. We'll also be putting other content on there. So be sure to click subscribe and you'll be able to follow along with those. I know Miss Gayla, yesterday, she put a lesson on there that has to do with subject-verb agreement in the RLA subject. So that's a good one just to watch. It's about 30 minutes long, and you can just get a little bit of practice on that. We'll be adding more content on there. So I know a lot of y'all work, or you have kids, or your just schedules are all messed up right now due to the crisis that we find ourselves in. And the good thing about YouTube versus just being live on Facebook or Zoom meetings, no matter when you get to this, you can watch it any time of day or night. You can fast forward it, rewind, make sure you get all the points of it. So if you have any questions, go to there and you'll be able to follow it, or contact your teachers as always. And as we do, it's the same slides we have all the time. Remember, while you're at home, you have access to everything you had in class. So please access them, get on there, use them, work it. We want you to be ready for when the tests come back around, and that should be sooner than later. And we want you to be ready for that. These are good resources in all that. Also, if you need information with logins or any of that, if you've forgotten and you can't get into it, email us, contact your teacher through Remind. I know that a lot of y'all are working really hard on that, and we want to keep that going. We don't want you to have to slow down and get anything that will keep you from getting into there. So please contact us, get the information so we can get you active on what's going on. I'll emphasize this again later. Math, math, math. Practice, practice, practice. You need to do it. Khan Academy is a great place for that. Please access it. Use the code so you're joined into our class, and that way we can see what you're doing there. But that is a great resource to build that fluency that we'll talk about in just a little bit as well. And as we always do on here, Smart Start. It is another option that we have. It's through Canvas. It's online in its entirety, so that's good with that. It's free. It's great, and it will help you to be successful when this is all over and you're looking for jobs there. If you have any questions about that, email adult.education@rcsd.ms. Contact your teacher. Whatever you need to do to get in touch with that. Now today, we are talking about math, and we're going to continue the progression of math skills for the high school equivalency exams. We started with basic operations. We moved into more of the squares and square roots and some of the things that kind of go in with that, and we're going to continue that same thing today. Now, if you notice my background that's behind me right now, as well as the background for the slideshow there that you're hopefully watching, and not just watching me, is ancient Greece. That's part of the Acropolis in Athens, and all of that there goes in with what we're talking about today, and that's we're doing math featuring Pythagoras. Pythagoras was a Greek mathematician who, when you look him up, he didn't eat beans. He was a vegetarian. That's a weird little side trail that I spent some time on yesterday looking. But he's also very kind of the founding part, even though he might not have been the first, he's the one that we credit with what we're going to be working on today. You've probably heard his name, the Pythagorean Theorem and things like that, which we'll be talking about in just a little bit. But that's why we're inspired by ancient Greece today, and that just looked like a pretty picture. So I liked having it in the background. Again, I mentioned it a little while ago with Khan Academy. It is important that you are fluent with your basic math operations. As we go into what we're doing today, we want to make sure you're able to go through this and just do it. And if you're not fluent, if you're having to stop and think as you're going through these lessons, it's going to really slow you down. And again, I mentioned it in the previous lessons. Those are the time killers that just sink you on the test. So we want to make sure that you're not being sunk and you're not starting off in a bad spot. So you need to be fluent in those operations. Multiplication is one of the basic operations that we talked about, and this is something we've used in the previous weeks. We've talked about squares, and it goes with the multiplication chart and its connection to area. And if we start to think about multiplication, and if you think about it with area, it makes a whole lot more sense than just, oh, this is multiplication. There's very few problems that they're going to give you what's 18 times 5. But they're going to give you other problems that use that same information. And with squares, a square is a square. I mean, it's a square. When you have a square, it has the same length and width. So the sides are the same on that. And that's where it fits perfectly into the multiplication chart that you know and love, or know and hate, from when you were in elementary school many years ago. When we see the chart here, you can see this is just 1 to 9, because that what fit on the paper pretty well on the screen there. But if we look at, for instance, 4 times 4, okay, that makes a perfect square. It has across the top there's a length of 4. It goes all the way across 4, and it comes all the way down 4. So when we see that across and down, it goes 4 by 4. Well, 4 times 4 is 16, and that's where it is in that bottom part there. And when you're looking at it, this lets you know, and this is how you can kind of get your mind wrapped around what squares actually are. They're saying there are 16 little squares that can fit on top of that shape, 4 by 4. When you have 4 across the top and 4 across the side, that makes 4 times 4, which makes 16. So seeing this and understanding this at this basic level is going to help you better understand what we're going to be doing in a little bit. Here's another one there with 7. 7 times 7 is 49. There are 49 individual little squares on that 7 times 7 square. And that's something that, and you can do it with all the different numbers there. At 1 times 1, there's just 1 square. 2 times 2, there's going to be 4 squares. All the way down through 81. You can see each one of those makes a square stacked up on top of itself. And as you see all those squares that are there, you start to better understand how squares work, and how, when you look at it, that's how many are there. And if you notice, just coming right down at an angle through there, that's where all your perfect squares are, just right there in the middle. That's a good way to help you better understand why multiplication has a direct correlation to everything else you're going to be doing with geometry and what we get into today, which is geometry as well. But it's important to know those squares. And again, they come back to just multiplication. And what's multiplication? Multiplication is repeated addition. So we have repeated addition, we have multiplication. It's all part of the same thing there. So it's important for us to look at that. Now, with this, again, multiplication, it's used in squares. This is what I was just saying. The previous slide, it all shows it as a chart. But on this slide here, you can see just 1 times 1 is 1, 2 times 2 is 4, and it has all of them written out. And if you notice in the third column here, we're pretty good on the first 2 columns, maybe. I mean, we might forget a few of these in this, like the 121, that's one that people mess up sometimes. Maybe your 7s and 8s, people get a little confused. But as we look into this last column, and we're looking at 13, 14, 15, 20, and 25, those are a little harder for us to memorize. 13, 14, Miss Wanda gave us a good tip about this one a few weeks ago. If you notice, if you can remember, 13 times 13 is 169. 14 times 14, you just swap the 9 and the 6, 196. For the 15 times 15, if you can just remember 225, it's not too hard to have to memorize just 2 or 3 things. That's not much. If you repeat it a few times, you look at this a few times, you practice this a few times, you're gonna pick up on those. 20 times 20, that one's pretty easy. Look at the 2's and just add 2 zeros to it. So if we have 2 times 2 is 4, well, 2 times 2 is 4. There's 2 zeros there, and we add those zeros in. So that one's pretty easy to remember. And then 25 times 25. That's a little bit harder to remember, but if you can remember that 5 times 25 is 125, that kind of helps me remember this one. I see that, and I know that 5 times 5 is 25, so I know it's going to end in that 25, but then the other parts that kind of go into there, it's not exactly the same way, but it's just a way that I kind of remember that a little bit better there. And really, if you look at that, 20 times 20 is 400, and then 5 times 5 is 25, but if it kind of keeps that, it's 5 times 5 times 5 times 5, and you kind of keep some of that. It helps you to remember that a little bit better there. But if you can remember these, this is going to help you pretty good on the information that you're going to have to do, especially for what we're doing today, knowing just these that you see on this screen. There are a few today. You can use a calculator. I'm not going to lie. I use a calculator in doing some of the practice just because as we get into the next couple of parts, it's not super easy mental math. Some of it you can very easily do, and I want you to see that as we go, that it is easy to do a lot of these in your head without very much effort. I mean, it's not too much to it as long as you know your squares decently. All right, now we're talking about the squares on the past slide. It was 1 times 1 or 12 times 12. Now on this next slide, all I've done is just change it to be to the square root. I use the exponent to show, or not the square root, the square of the number. So down here in the bottom corner, 6 squared, or 6 to the exponent of 2, is 36. Same thing I did in this third column that we're not familiar with as well. 13 squared, or 13 to the second exponent, is 169, so forth and so on. So as you see those, you start to see how that works. You start to see the pattern. The reason I take the effort and the time to type all these out and to show you, I want you to make the connection, and hopefully you won't get dizzy. I'm going to back up for a second. From this slide that you're seeing right here, and seeing where those are, and seeing the squares that are on these, I want you to make a connection from this to this one to this one. And as you see all of these going across, you see the connection to these, and that brings us into the next slide there. When you're looking at squares, squares are the opposite of square root. So as we're looking at these squares, like I'll use 6 squared again. 6 squared is 36. Well, 36, the square root of 36 is 6. So if you see how it goes up to the point and then it comes back down from the point, it helps you to see a connection, because today we're going to be doing both of these. We're going to be squaring, and we're going to be finding the square root of certain things. So it's important for us to be able to look at that and see that. As we're going through this, a lot of this today is going to be like I said, using this, and if you know those squares and you understand that a square root is the opposite of the square, like over here, you have 12 squared is 144. Well, the square root of 144 is 12. Just start to kind of learn that. I always teach these together, and I teach square root and exponents and the squares and stuff when I teach multiplication. That's what we've done over the past few weeks, because it's all the same skill. And I don't like to say, oh, well, we'll get into square roots later because that's hard. Well, no, it's the same thing as multiplication. It's just the opposite side of it. So as you see how all that kind of works together, it just makes it easier to learn. And that's one of the things I want to make sure that you're understanding as we go through this today. All right, so now let's look more at Pythagoras. Let's look at what is the Pythagorean theorem. And we're talking about this and we're saying, okay, well, squares are used in the Pythagorean theorem. But you may say, okay, great, that's wonderful. Squares are used. I appreciate that. What's the Pythagorean theorem? And as we're looking, I'm going to give you a definition here that helps you to better understand what the Pythagorean theorem is. It just kind of says it all right out, and then we'll explain it as we go through. But this is something that we're going to be using for the rest of the class today. The whole class is pretty much on Pythagorean theorem. I want you to be able to understand and see how this works. And again, it's going to be using the squares that we've been talking about. The basic formula for the Pythagorean theorem is ABC, or A squared B squared equals C squared. That's it. That's the Pythagorean theorem. Now, yes, I have little Michael Jackson there and the Jackson 5 dancing along. It's almost as simple as 1, 2, 3, A, B, C, 1, 2, 3. And I won't sing or dance for y'all, but it really is almost that simple as we start to see this today. But if you need to remember on this, A squared plus B squared equals C squared. And it's not that hard. If you take a couple seconds now and look at that, you can remember A, B, C, and then you remember squared. That's all you got to remember, A, B, C, and squared. A squared plus, so remember a plus in there, B squared equals C squared. That's, if you can remember that, that is the Pythagorean formula. Now on the test, they give you that, but if you're having to stop and go look at the formula sheet just to get A, B, C, come on now, do a little bit of work, okay? It's not too hard to remember that one. And as you notice today, I'm going to put it on the slides when we're doing things several times, because I want you to be familiar with A squared plus B squared equals C squared. And I'll slowly fade it out on the slides because I want you to start to burn it into your head. A squared plus B squared equals C squared. All right, so as we're looking at this, here's the definition of the Pythagorean theorem. Again, A squared plus B squared equals C squared. In a right triangle, so, and if you notice here, I highlighted certain words in bold. The first is right triangle, so it has to be a right triangle, and that's where one corner equals 90 degrees. We'll talk about that a little more in a second. The square, again, another bolded word, the square of the hypotenuse is equal to the sum of the squares of the other two sides. All right, so there's some key things there. So when we're looking at this in a right triangle, so if it's not a right triangle, you're not going to be able to use the Pythagorean theorem. All right, so it needs to be a right triangle. Now, with that, if we have a rectangle or a square or a cube, there's right triangles in that, and that'll be a lesson for another day. But it's important. You have to have a corner, a spot that is a right angle, and it forms the right triangle there. All right, and then it talks about the square of the hypotenuse is equal. So the square of the hypotenuse, that is the C squared. That's going to be our hypotenuse. And it says C squared, the square of the hypotenuse is equal to the sum. What does sum mean? Sum is the addition part. So when we see addition, that's the sum, and it's of the squares of the other two sides. So the other two sides are going to be A and B. And it's asking us to do the sum of the squares of those two sides. So as we see that, and we're looking at this, all of that different part, it's saying two sides, A and B side, the squares of those equal the square of the hypotenuse. And I'll show you some stuff in just a second that lets you better see this and understand this. All right, so that's what the Pythagorean theorem is. That's the basics of it, and that's the definition of it. If you're confused later, you can send me a message. I can give you some more information on it. The other great thing to do is go to Khan Academy and put in Pythagorean theorem practice. You can work as many practice problems as you want. I'll give you some today, but as we go through, you might want some more practice at home. That's going to be your best way to get to there, is to do some of those things. All right, so we have a right triangle. How do we know it's a right triangle? This is one of the first things people go, is it a right triangle because it's pointing to the right? There's a way you can tell what a right triangle is. The easiest way to determine a right triangle is to look at the corner. If it has a little box drawn in the corner, the little window there, that is telling us it is a 90-degree angle. All right, so we see this right triangle on the screen. It has a 90-degree angle, so that lets us know that is a right triangle. In math and on the test especially, they're going to let you know what the angle measure is. They're not going to make you have to assume or guess that a triangle is a right triangle or not. They're going to give you that information. Part of it also will be in what they're asking you to do. If they're asking you to find the Pythagorean theorem, more than likely they're going to tell you it's a right triangle, or it's understood at that point that it is. A lot of that will come from just practice, taking the practice tests, getting involved in your lessons and doing some of the things. You'll start to see this. You'll get a little bit of practice in those in different areas. And the more familiar you'll come with it, the better you'll be at it. That's the reason I talk about fluency with your basic operations is so important. Well, fluency in just the problems and the way they ask the questions on the test is important as well. So the first thing is it's a right triangle, so we're good there. The second part of the definition, it said the hypotenuse, the square of the hypotenuse. So what is the hypotenuse? The hypotenuse is always across from the right angle. Okay, so if you look at that 90-degree angle in the bottom corner there with the white square, directly across, it's opposite the angle there. The one that's opposite that angle is the hypotenuse, and it will be represented by c squared that we'll see in just a second. The other two are the sides. We have two sides. Does it matter which one's A and which one's B? Which one's B and which one's A? It's not. Because of the commutative property of mathematics, is there a difference between 3 plus 2 and 2 plus 3? No. 3 plus 2 is 5, or 2 plus 3 is 5. Either one, you get the same thing there. So it doesn't matter the order that we do those, in which side it is. I usually work like I read a book. I work from left to right. I start on one side of my page and go across and make A and B. It really just kind of depends. You'll see us as we practice some today how that works a little bit. So we need to know a right angle is a right triangle. The hypotenuse is opposite that right angle. And then the two sides are the other two parts of the triangle, because triangles only have the three sides. Now, as we are looking at this, again, it's a right triangle. I did not put a little square in the corner. It's just the same one from the page before. I just left it on there. And now we see this little drawing here. And it's gonna have an animation so you can see. But if you notice, it's upside down, but I wanted to keep all the angles the same. Over here, you see an A. Down at the bottom, you see B. And then you see C over here on the hypotenuse. And we talked about that with A, B, and C, where each one of those are. But if you notice, it's just going to twist around. You have the A, B, and C squared. As it kind of twists around, you see that it could go any direction. It's not going to change where they are. And now we can see everything in the right spot. Now, as on this slide, you see that the angle at the top, that's where that right angle is at the very top there. Okay, so opposite that is where you see the hypotenuse. It's directly opposite that angle. And as we're looking at the hypotenuse there, we see it's C. And remember, we talked about this, and I forgot, I guess I thought I had it on here, but I didn't. A squared, so if we have a squared plus b squared, it equals c squared. Okay? Forgive my writing with a mouse, I'm not so hot with that. But as we see here, a squared, we have, this is our a box over here. If a squared and b squared, if we add those two together, that's going to equal c squared. Okay, and we'll see that in the next little slide how that comes into play. But that's what we're doing here. We're looking at the square root of a plus the square root of b equals the square root of c. And that's what the Pythagorean relationship is, and this Pythagorean theorem that we're looking at. Okay, so here we have another right triangle, and I put it on graph paper so you can kind of see how the different parts make up here. And with this, we know at the top, there's our Pythagorean relationship, so we're going to see how this kind of works out. Well, at the bottom, if we're counting the big blocks, you see it's 1, 2, 3 units wide. All right, so the bottom of this one is 3 units. And if we square 3, 3 times 3 gives us 9. So that box is worth 9 squares. On this B side, you can see that it's worth 4 units. It goes from the top, from there to there, that's 1. From there to there's, well, that's 1 up at the top. There's 2, there's 3, there's 4. So those are our 4 units there. And when we see that one and we look at it, we know that it's 4. 4 times 4 is 16. So 9 and 16 is this side. And then we look at C, and it's a little bit harder to count the units on that one because of being at the angle how it is. That actually gets into coordinate geometry. You can determine the length of that, but take my word for it on this one, it's 5 units big. And what this does, and the way you can kind of see how this is proven to be true, let's use the formula. If you notice at the top, it said a squared plus b squared equals c squared. Well, if you watch it, it changes. 3, all I did was took the a that we had down there at the bottom, and it's 3 squared. And then I took 4, and I put it in the b spot. 4 squared equals 5, which is the c squared. When we follow this out and we work out this formula, 9 is 3 squared plus 4 squared. That's 9 is 3 squared plus 16 is 4 squared. 5 squared is 25. So these are just our squares. It's just 3 times 3, 4 times 4, and 5 times 5. Again, going back to basic multiplication is the only skill that we're having to use to do that. It tells us that the left side there, 9 plus 16, equals 25. On the right side of the equal sign, 5 squared equals 25. So when we get to the bottom of this, is that true? Are those numbers right? Does 25 equal 25? And it does, because that's how that Pythagorean relationship works together. If you added up all the squares on the A point, all the squares on the B point, it would equal the same number of squares on the C point. That is how this whole Pythagorean relationship works. Pythagoras determined and understood that that's how that whole situation worked. Now, in the background of the picture that you see here, the one right over my head, you have the Acropolis that was built there. It was amazing how well those structures that were built thousands of years ago, how they still are standing. Now, some are in ruin, as you can see in the picture behind me. There are definitely some ruins on there, but, and I know this is kind of small at the top, but that main structure there, the Acropolis that you see, it's amazing how large that building is and how straight it is. Part of the reason why they understood right angles, they understood this geometry to build such amazing structures there. And we're going to learn and get to practice a little bit of that as we go. All right, so here's a chance you'll get to practice this same thing. And I'll work through this one with you, and then I'll give you some time to work out a couple more of these as we go. Now, if you're watching this on YouTube, you can pause it and try to answer this on your own if you think you've got it. If you're watching it with us now, I'm going to kind of work it together with everybody so we can see how it goes. So on this, we have a triangle, and just ask yourself first, is it a right triangle, and how do we know? Yes, it is a right triangle. Why? It's got the little house in the corner. When it has the little window thing in the corner, that's the sign that lets you know that it's a right angle. All right, so we see that. And then we see at the top, it tells us a squared plus b squared equals c squared. Like I said, I'm giving you this so you can start embedding that into your head and you get it burned into your memory. All right, so we need to know which is which. A and B are the sides and C is the hypotenuse. Well, in this particular equation that we have and the particular triangle, there's a question mark on that hypotenuse. So we know that's the one we're looking for. So over on the right side of the screen, and I would do this if I was working it out on my own paper, on my right side, I would put my formula. I would just write it out right there. I'm not going to try to do some steps in my head. That's where people mess up sometimes, especially on here when we think we know what we're doing. That's where we get a little bit dangerous. So what we want to try to do is make sure that we write the formula down and then we plug in the pieces and we plug in the parts in the proper spaces. All right, so what I did, I just took the different parts. I made 6 be my A, and if you notice, it's right under A. I made 8 be my B, it's right under B, and then I left C as the hypotenuse. And all I did is plugged in the first 2 parts that I knew. And I'm left with the third part, which is what that hypotenuse is. All right, so we have the first 2 portions. We don't have the last one. So then all I'm doing is finding what is 6 squared plus 8 squared. I see those 2 parts. So the first thing I'm going to do is just do those squares. 36 is the square of 6. 6 squared is 36. 8 squared is 64. I just wrote those down. I didn't try to add them together yet. I didn't try to move a step forward. I wanted to do just that one step. That way I could make sure that I'm not messing something up as I go. All right, and all I did, I'm still bringing that c squared down on the end. Well, 36 plus 64 equals 100. So I add those together. 100 equals c squared. So now I have those 2 points, I have those parts, and I've got to see, okay, what's the next step? Now, this is something that we haven't talked about too much. It is, like, don't mean to scare you here, but this is a little bit of algebra, but I do this intentionally because I don't want you to be like, oh, I can't do algebra. All we're doing here is finding what is the square root, because remember we talked about the opposite of the square of something is the square root of something. So when we have this here, we still have c squared and we have 100, and that's not giving us an answer. We need to find out what's the square root of c and the square root of 100, and that's what the next step is. All I'm doing on this, I'm looking at this and I'm saying, okay, what is the square root of c squared and the square root of 100? That's what I'm trying to do there. I want to look at those parts to see what is the square root of each of those. All right, so as I'm looking at the square root of each of those, well, the square root of c squared, that's just going to be c, and the square root of 100 is 10, because 10 squared equals 100. 10 times 10 equals 100. So what would the answer be for this one? The answer would be a squared plus b squared equals c squared. If a is 6 and b is 8, then that means c has to be 10 in this particular problem that we have there. All right, so it would be 10. And that's all I'm doing here. I'm just plugging in those parts. It's multiplication and finding the square root, which is just figuring out what times what gives you that number. All right, so that was the first one that I did. I'm going to give you a couple seconds to do the next one here. Okay, if you need to look at this for a second, jot it down. Make sure you write all those steps down so you can follow along and just try to repeat that process on the next problem. All right, so here we are to the next one. Same setup. I give you the a squared plus b squared equals c squared at the top, and then I have 5 on one side of the right triangle and 12 on the next side. So we're still looking for the hypotenuse. So take a couple seconds. If you're on YouTube watching this and doing it along, you might need to I'm going to give some time there. If you need to fast forward to get to where the answer is and where we start working it out, you can fast forward. But I'm going to give the people here right now a couple seconds to work this out. When you get it, you can send the answer via a private message. And if you're not sure how to get started on this, remember, use the formula, and then you're going to plug in the numbers. So it's just like we did before. All right, if you're working it, let's see if you're following the same steps. And again, you can always send me the answer as you go. If you get it, if you have a question, ask, and I'll be more than glad to help that out. And you can just send the message to me. You don't have to send it to everybody in the group. So we have here, I put the 5 as the A position. I put 12 as the B position, and we're finding the squares of those. So 5 squared is 25. 12 squared is 144. And that equals C squared. Okay, so we just multiply those because we're doing the exponents and doing the basic operations there. As we move to that, we're just going to add 25 to 144. When you add those together, you get 169 equals C squared. Now, like we did on the last slide, this seems like, okay, well, I'm done. Well, no, we still have a squared over there with the C. So we're going to have to find the square root of both of these problems. And as we do that, we're going to find the square root of C squared, and we're going to find the square root of 169. The square root of each of those gives us 13 in C. So the answer to this one, what's the hypotenuse, or what's C squared for A being 5 and B being 12? It gives us 13. 5 squared is 25, 12 squared is 144. Add those together, it's 169. The square root of 169 is 13. And that's the Pythagorean relationship for that one. All right, any questions on that one? All right, you can see it there. If you need to, if you're watching this on YouTube, when you go to the next problem, if you're stuck, just rewind a second, see how it's set up so you can see how to do the next problem. Now, the next problem gets a little hairy, and I say that because I don't know my 24s. I don't know what those are. This is where it is completely appropriate to get a calculator. All right, because if you have a calculator, you will be able to just punch in what's 24 times 4 and work that out. There's no shame in that. I don't have my 24s memorized, so don't worry about that one. All right, so we're going to give you a couple seconds to work that one out. When you get it done, you can put your answer in the chat box. right, and the first step that we're going to do on this is write the formula. Once we have the formula written, we're just going to plug the numbers in. 7 squared plus 24 squared equals c squared. Then we just do the math for that. 7 squared is 49. 24 squared is 576. We add those together, and that gives us 625. That one I do know. I do remember that one. Even one of the slides at the beginning of this presentation, we did that one. But how do I find it? I'm going to find the square of each side of those. The square of 625 and the square root of c squared is going to leave us with 25c. So the answer to that hypotenuse is 25. A squared, 7 squared is 49. 24 squared, that's b squared, is 576. Add those together, it gives us 625, which is the square root of 25. So that's c squared. All right, so as we're looking at this, if you notice there's a little bit of a pattern. You can start to see a pattern when you're doing this. They call them Pythagorean triples. And as we're looking at it, just the examples that we used, the one from the lesson when we were talking about it, 3 squared plus 4 squared equals 5 squared. Then there was 6 squared plus 8 squared equals 10 squared. And then 5 squared plus 12 squared equals 13 squared. And 7 squared plus 24 squared equals 25 squared. If you notice there, it's patterns: 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25. One of the coolest things about the Pythagorean theorem, and this is where my brain works, I try to work smarter, not harder. You will start to see relationships between numbers. If you see a Pythagorean problem with a 3 and a 4, instantly you should know it's 5. The same way with 5 and 12, if you see that, you should know it's 13. But this also works in a different way. If you see 5 and 13, you can know that the other one's going to be 12 as long as 13 is the hypotenuse. So you'll start to see some of those connections there. To keep them easy on a lot of these problems with whole numbers, this is what it's going to be. Some of the problems, they do get to be fractional answers or decimal answers, and that again we'll talk about on a later day. But right now I want you to start to see some of these connections, some of these Pythagorean triples that are so good. Again, these are the ones that I mentioned that we just looked at. Some other examples of some triples: 20, 21, 29, 12, 35, 37, 9, 41, 40. You see these numbers, and a lot of times, if you notice, they're not far from each other. Like here you have 20 and 21, and then you have 29. Here you have 12, and then you have 35 and 37. There's a 9 here, and then 40, 41. A lot of times the numbers are kind of close. That kind of helps you to see a little bit of a reasonableness of an answer. If nothing else, you can just kind of to guess. If you get some weird answer and it doesn't seem to make sense, then you might want to check your work again. These are some of the things, again, when you build that fluency, you'll start to better understand. You'll start to get some good ideas about some of these things. And that's something that I want to make sure that you're paying attention to there. Okay, so here's another one where we're doing it a little bit different. As we're looking at this one, now we have a hypotenuse. We have a side, we have the hypotenuse, but we don't have this other side. So as you go to work this one, and again, if you're on YouTube, if you want to pause it for a second to see if you can work it, go ahead, press pause, work it out. If you're here with us live right now, I'm going to kind of talk through it a little bit as we go so you can still keep kind of working as we do it. What do I always start with? Always start with writing the formula out. And now I'm just going to plug in the numbers where they are. I'm keeping A being on the far side. I'm keeping the hypotenuse as the hypotenuse, and B is the one that we're looking for. So I just plug in my numbers. 3 squared plus b squared equals 5 squared. So I've got that in, and now I go, okay, let me do those. And I just work out the math. 3 squared is 9, b squared, I don't know yet, and 5 squared is 25. So I do that, and everything's good. Now, this is where I have to do a little bit of algebra. I do have to get rid of this 9 on this side so I can leave b by itself. So I have the 9 and I have the b squared. What I'm going to do is subtract 9 from both sides. I take 9 away from this side and it cancels out. I take 9 away from this side and it ends up with 16. So now, once I've subtracted 9 from each side, now I have b squared equals 16. And just like we did a minute ago, I find the square root of each of those, the square root of b squared and the square root of 16. That leaves me with b equals 4. Now, I hope some of y'all already knew the answer to that because of the last slide that we talked about in the Pythagorean triples. If I flip back real quick, the very top one that we had, well, it's not going to let me flip back that quick, but the very top one that we had was 3, 4, and 5 were a connection. That's a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. So as soon as we saw a 3 and a 5, we should have automatically known the answer to that one was 4 because we know the setup that's there. You might could do that same thing looking at this next slide. All right, so as I click over to it, we see we're looking for the A side now. We have a hypotenuse of 13, one side of 12. So instantly, I know the answer because I know my Pythagorean triples that we talked about a second ago. And even though I know that answer and I know what it's going to be, I want to see if I can work it out to make sure that that's the answer. As I do this, again, if you're on YouTube, this is where you might want to press pause so you can work this problem out. If you're here in the class, you can kind of work it as I'm talking through it. So the first step, I write the formula. And again, even though I'm doing a little bit harder problem, I don't change my pattern. I follow the same pattern every time I work the problem. That way, all I'm having to do is just repeat the pattern over and over again. So a squared plus b squared equals c squared. I plug in my different parts. A is the one I'm looking for, so I don't have it, but 12 is b, so I put it there, 12 squared equals 13 squared. So I put those parts in, then I move to the next part. I find the squares of each of those. A squared is still sitting there, but 12 squared was 144, 13 squared is 169. Same way I worked the last one, I have to subtract 144 from both problems, both sides of the problem. So that leaves me with a squared equals 25 because 169 minus 144 is 25. My last step before the answer, I find the square root of each of those. The square root of a squared is going to be a. The square root of 25 is going to be 5. And that's my answer. It's 5 because 5, 12, and 13 are a Pythagorean triple, but also it shows that connection and how it all works together. I can see and solve my answer. Now, I know what a lot of people usually ask. Why on earth do I need to know this? This is something from ancient Greece. Why do I need to do this now? Well, a couple of very practical applications of this come from stuff that people are doing right now. I see it all the time. I'm actually in the process of building a little container garden in my backyard. And guess what? I want to make sure it's square. How can you make sure it's square? You can use the 3, 4, 5 relationship. It's called the 3, 4, 5 rule. If you ask anybody that works construction, they may not know Pythagorean theorem, but they may say the 3, 4, 5 rule. And what the 3, 4, 5 rule is, if you want to make sure your corners are square, you can measure 3 feet one way, 4 feet the other way, and where it's 5 feet in between them, as the woman in the picture is measuring there, at the point that it's 5 feet, that means that corner is square. That is something that it will, as long as one side's 3, one side's 4, and the other's 5, it will keep the square there. It also is used in construction, as you see there in the picture. How can they make sure that it's perfectly a 90-degree angle there going up? It's going to be 3 feet by 4 feet by 6 feet. They can measure that. and the 3, 4, and 5. That gives them that rule, and that's that connection that shows that that's a 90-degree angle. They'll measure it a couple different ways to make sure that's where it's at. It's an easy way, and this is partially why the Parthenon that you see in the picture there on the Acropolis is so amazing. They use this to make sure everything is at perfect angles, and everything was set up and perfectly lined up to last all those years. Another practical example of this is this next problem. You need to reach the top of a wall that's 12 feet tall. To be safe, the ladder needs to be 5 feet from the wall when it leans up against the wall. So what size ladder would allow you to reach it perfectly? Okay, you need to know exactly what ladder is going to reach that point. All right, so if that's what you're trying to do, we need to know the Pythagorean theorem. We're going to have to use this the same way. And as you can see in the picture there, I've seen problems exactly like this on the test. It's important for you to understand this. Now, looking at it, we see 5, we see 12. Those are my sides. So instantly, we should already know the answer is 13 because we know how to do this. We know those triples, 5, 12, and 13 go together. But let's work the math to see and to see how it works out. So we start by writing the formula. A squared plus B squared equals C squared. And then we plug in the parts that we know. We have our two sides, A squared plus B squared. And then we have C squared. What's the math of those? 5 times 5 is 25. 12 times 12 is 144. That equals, when we add it together, the 169. And that's 169 equals C squared. And I did forget, now that should be C squared there. I got a little ahead of myself as I was going through. But when we get the square root of each of those, that's what gives us that 13C. All right, that's what gives us C is 13. So what ladder would fit perfectly in this situation? A 13-foot ladder. 14-foot ladder could be too high. 12-foot ladder could be too short. So we want to make sure that we're reaching that thing. I've seen some problems like that before when they said, would a ladder this tall fit on this, or be too big or be too small? So you've got to kind of understand how this concept works as you're looking through all of that. All right, so as we wrap up, the last couple things I want to share, if you'd like more practice, let me know, let your teacher know, send them a message to remind, send me an email. I'll be more than glad to help with any of that. Also, Khan Academy. I can't emphasize enough. All you got to do is put in Pythagorean Theorem or Pythagorean or Pythagoras on there, and it's going to have videos. It's going to have practice problems. Again, use our class to join. We'll be more than glad to help you out any way that we can on that. Now, next week, we will have another Live with Andrew. Look for this lesson later today on YouTube. And any of the other math lessons, they will be being put up earlier that we recorded, will be put up later this week. We did not record them initially, and now we're having to go back and record them, and that does take a little bit of time and effort and energy. So if you haven't gotten into the lesson and you hadn't seen those yet, be looking on Facebook, because this lesson as well as others will be on there. You can watch them as many times as you want to. And yes, I am eyeing those lessons. I look forward to these lessons and being able to help y'all out any way that we can. All right, thank you for coming today. I hope that you got the information that you needed. I hope that you are comfortable with this now, and I hope that you will be able to do the Pythagorean theorem better. If you have any questions, you can put them in the chat box or email me at adult.education, and I would be more than glad to help you out. And if you have other subject areas, other parts of math you'd like to see done live, let me know. I can do those too. Stay safe and have a great day.